Uh, Hello, we will present you today Cocos AI, Confidential Computing System for AI. I am Darko Drašković. I am Senior Software Engineer at Ultraviolet, and my colleague is...
Hello, my name is Filip Bugarski. I'm software engineer at Ultraviolet, and I'm creator of Cocos AI user interface.
Yeah, and I'm one of the lead architects of Cocos AI system. So first few words about the project itself. It's done in collaboration with the University of Belgrade School of Electrical Engineering. It's one a very important academic institution in Serbia, and it's one of the largest engineering faculties in Europe. The whole project is funded by the Innovation Fund of the Republic of Serbia. It's a key state institution that supports innovative activities in the domain of computer science and information technology in general. So what is Cocos AI and what you can do with actually Cocos AI? So Cocos AI, or Confidential Computing System for AI, lets you run AI and ML algorithms on combined data sets. It means that you can use multiple data sets, you can combine these multiple data sets, and you can run different algorithms on these data sets. Now, what's the specifics of Cocos AI in relation to that? Because that's a standard AI ML setup. Well, the specifics of it is that it all happens in so-called trusted execution environment or in secure enclave. Those are terms that are like related to confidential computing. Those are used convertibly. And so the idea is to put everything inside the secure enclave, algorithms and data sets as well, and then to apply this algorithm to a data set. So one company could put an algorithm in a data set, other companies, an algorithm in a secure enclave, and other companies can put data sets in a secure enclave. And the idea is that neither the AI company that puts an AI algorithm or data companies that put data in secure enclave can access actually this data, because this data is hardware encrypted. What is more, this data cannot be accessed by system administrator that provides infrastructure for the secure enclave, or a cloud provider, or even operating system where the secure enclave is operating, including hypervisor, but let's not go into these technical details. So a few words about the architecture, or let's say ontology also of Cocos AI. Cocos AI is like have three basic entities. It has users, organizations, and computations. Users normally belong to organizations, and computations are like our representation of algorithm and data set descriptions, as well as algorithms and data sets themselves. So we have also a manager, VM manager, and just to say a few words, our secure enclaves, so trusted execution environments, are implemented as virtual machines. So we have a manager that manages these virtual machines. We will say a few words about the manager. Then we have a special piece of software running inside the very trusted execution environment or inside the secure enclave, which is an agent. We will say also a few words about the agent. And then we have a client, command line interface for communication in the enclave. It is used to upload data and upload algorithm. It is used by the companies from the previous slide, and it's also used to now download the result. Normally, not everyone can download this result. And finally, we have UI, which is used for basically CRUD operations over users, organization, and computation manifests. Computation manifests describe computations themselves. And Philip will say a few words about UI. So this is for the architecture. Just to repeat it, we have like this four main pieces of architecture. We have manager, agent, we have CLI or client, and we have UI. And also backend UI is communicating with this backend, which then communicates with manager, and that's about the flow, but we will talk more about it. So if you look at the diagram on the right, it's basically a more or less an overview of the entire architecture. It's a more like a closer picture of the architecture than the previous slide. Previous slide shows you different possibilities of deployment of our system, but this is more specifically how system works. So basically on this slide you have manager, and a few words about the manager. Manager is an executable. It runs on AMD secure encrypted virtualization server. So this AMD SEV, secure encrypted virtualization server, enables us to launch virtual machines which has a random access memory encrypted. So those are like what we mentioned, hardware encrypted enclaves, where we put data sets and algorithms. But manager is specifically, so manager here is specifically responsible for putting a computation manifest file in VM's virtual disk drive, then it boots VM, and finally, when the computation is done and the algorithm is applied to data sets and results are sent to the result recipient, it shuts down the VM. So we have like one VM per computation. So if you look closely at the picture, UI sends actually computation manifest to manager, and then manager is responsible for putting this manifest inside a virtual disk drive, and then it boots this VM. So it boots the VM, and then it once the computation is done, we will say a few words about this. It shuts down this VM. We'll get back to this slide just to say a few words about agent. Agent is a Linux process that runs as a daemon. It means it runs in a background. If we get back to the previous slide, this is the agent. It runs in a VM, which is launched by manager. And basically, agent is a gRPC server. So that's one of the basic roles of agent. It means that we can use now CLI to send data sets. So company 1, company 2, company 3 from the previous slide can use CLI, command line interface application, to send data sets and algorithms directly to enclave. Normally, all this communication with the enclave is encrypted, and also it uses mutual TLS for authentication of parties, etc. And once we receive all the algorithms and data sets, so we are still talking about agent, its role is to receive all the algorithms and data sets. It will consult a manifest. It will then ask whether we received all the algorithms and data sets. If not, we will listen for more algorithms and data sets. And once we actually receive all the necessary algorithms and data sets, so like manifest tells us if we receive all the algorithms and data sets, we will start the process of agent will start the process of computation. That means of application to algorithm to data sets. And once the process is done, it will get back to listen state and wait for the result consumer to send a get request for, let's say, get request for results. And once it's done, it sends a computation result to a result recipient. And next, it ends its operation. And once it ends its operation, then, as we said, manager shuts it down. So this would be the basic overview of how our system functions. So one very important aspect of the system is attestation. Was the attestation? Well, we need to like a guest owner. It means a owner of the virtual machine with an encrypted RAM needs to be sure that nobody tampered with the virtual machine and that nobody actually tried to replace one virtual machine with another. So it needs to be sure that it's his virtual machine that he is using, guest owner. So guest owner can use this attestation process, which is complicated and relies on very hardware, AMD hardware, to attest that it's really that he's really using his own like virtual machine. So like when we say guest owner, we really mean also companies that send data sets, companies that send algorithms, and finally the company that receives results. So that's all like, let's say, guest owner. Okay. So we will not go in the process, but that's a basic overview of the process. Finally, there is this UI that we use to create users, organizations, and computations. We will tell you a few words about this, and then we will have a small demo of how the system functions.
Thank you. Cocos UI or Cocos user interface is the visual and interactive component of a system that allows users to interact. It includes users where you can create, update, delete user accounts. You can also give it roles. Organizations, you can create, update, delete as well. And you can assign and unassign users to some organizations or unassign. At the end, we have computations where we can create, update, delete, and run computations. And now Darko will demonstrate to you the creation of a computation manifest and show you how to perform a computation.
So this will, thank you, Philip. This will mostly be a fictional example, but there will be some real processes in the flow. So we will go directly to the creation of a new computation. We have different options. I contrived an example, a possible example, which would be, let's say, a medical research analysis. We could have different data sets here. Let's say this data sets and okay, well, different data sets providers like this medical center invented, fictional, or this health science institute. And then let's say that this biomedical research center is interested in results, and also I forgot what here. And also, let's say we have like this data analytics lab. We will put some description. We want to perform confidential computation on medical data. What else we have? Like some interesting algorithms that we will use, like a convolution neural network, and algorithm providers are Algotech Solutions, and let's say, for example, Tech Neuron Industries. And we'll put some like metadata related to this computation. And we will submit and create this computation. So now we have like in the list of computations, our computation. Normally we can do all this by using a simple curl, but it's nicer to do it with UI. So we will look at our computation, and now we have a possibility to update or delete computation. But let's see what happens when we try to run the computation. So when I click on the run button, then I establish a connection to virtual machine. I see here virtual machine booting up. And this virtual machine is running our agent as a daemon, so as a process in the background. And normally, after a while, our computation is executed. So here I would like to conclude this presentation. Hopefully it was very nice, real and interesting. And I would like to thank you for your attention. Bye. Oh, so Philip forgot to turn on his mic.
I'm sorry.
Okay.
Thank you.
Thank you. Bye.